Yesterday evening at 9 p.m. Central European Time, NASA released the sharpest images we've ever captured of an interstellar object. What the Mars Reconnaissance Orbiter recorded answers some of our most pressing questions and raises new ones that are even more fascinating. Welcome back. Since July, we've been following the journey of 3I Atlas, the third confirmed interstellar visitor to our solar system. We watched its dramatic approach to the sun, documented its inexplicable brightness surge, and asked ourselves, what is this object really? On November 19th at 9 p.m. CET, NASA finally presented their most comprehensive data, a press conference summarizing months of scientific work, and today we're looking at what they found. The Mars Reconnaissance Orbiter, a NASA probe that normally maps the red planet, was positioned for an extraordinary opportunity on October 2nd. 3I Atlas was on the far side of the sun at that moment. For us on Earth, invisible. But for the Mars Orbiter, a once-in-a-lifetime chance. 30 million kilometers distance. That sounds like a lot, but in cosmic terms, that's a close-up. 10 times closer than 3I will ever come to Earth. What the HiRISE camera on board captured exceeded expectations. A clear signal, not a blurry smudge. A defined cometary nucleus surrounded by an active coma, the gas envelope that forms when frozen matter vaporizes. NASA Associate Administrator Amit Kastria opened the press conference with a clear statement: this interstellar object is indeed a comet, and it behaves like a comet. That may sound simple, but after months of speculation, could it be an alien probe, an unusual asteroid? This confirmation mattered. The images show more. A tail, not spectacularly long, but clearly present, shaped by the solar wind as 3I swung around the sun. And here's the fascinating part. The brightness surge we observed in late October, that unusual, intense brightening, wasn't an anomaly, it was normal cometary behavior, just at extreme scales. But where does 3I Atlas come from? This question is more complicated than it first appears. The European Space Agency has accomplished something remarkable over the past 2 weeks. The ExoMars Trace Gas Orbiter, actually designed to study the Martian atmosphere, observed 3I Atlas during its flyby phase. The result? The trajectory was determined 10 times more precisely than before. That sounds like technical details. It is, but the implications are enormous. Now scientists can reconstruct 3I's path backward with an accuracy that was impossible 2 weeks ago. Early estimates point to an origin in a region of the Milky Way we call the galactic fringe zone, an area between the spiral arms, cold, dark, rich in ancient objects that have drifted through space undisturbed for billions of years. But, and here it gets philosophical, we cannot say which star 3I originally came from. After 7 billion years, that star might have died long ago. Perhaps the system where 3I formed doesn't even exist anymore. We're looking at a messenger from a time when our solar system didn't yet exist. What do you think? How many such interstellar visitors pass through our system without us noticing them? 10 per year? 100? 1,000? Write your estimate in the comments. NASA didn't just show pictures. The James Webb Space Telescope, our most powerful infrared eye in space, analyzed the composition of 3I's coma. Result: carbon dioxide, carbon monoxide, water ice, dust, everything you'd expect from a comet. But there's a difference. The chemical signature, the ratio between the different molecules, deviates slightly from comets born in our solar system. Not dramatically, not mysteriously, but measurably different. This confirms what we suspected. Conditions in other star systems, temperature, radiation environment, available elements vary. 3I Atlas formed under different circumstances than our comets. And these subtle differences tell the story of its home. Another discovery: the surface is surprisingly smooth. You might expect an object that's traveled 7 billion years through interstellar radiation and micrometeoroid impacts to look scarred, yet 3I shows relatively little surface damage. Why? Possibly because much of its journey led through nearly empty space. The density of the interstellar medium is incredibly low, a few atoms per cubic centimeter. For 3I, that meant 7 billion years in almost perfect isolation. Picture that, 7 billion years, and it looks like it was formed yesterday.
Why do we care so much about a piece of ice and rock from an alien star system? Here's what NASA isn't saying loudly, but means. This was a test. A test for the day when an object really is heading toward us. Every day, millions of asteroids and comets orbit through our system. Most are known, cataloged, predictable. But 3I reminds us, our solar system is not an isolated island. It's part of a larger network. Objects wander between the stars. They carry information, chemical compositions, insights into conditions that prevail light years away.
NASA Administrator Kastria mentioned something else in the press conference. The precise trajectory tracking of 3I enabled by the Mars and Jupiter probes is a dry run, a dry run for planetary defense. If an object, interstellar or not, ever goes on collision course with Earth, we need to know its path with extreme precision. 3I Atlas was no threat, but it was an exercise, a chance to test international cooperation, coordinate telescopes, measure response times, and it worked. Within 24 hours of discovery, dozens of telescopes worldwide observed the object. NASA, ESA, private observatories, all shared data in real time. That's not a given. That's years of preparation, protocols, trust between nations. This matters more than you might think. 3I Atlas is fading now. Every night it moves farther from the sun. In a few weeks, it will be invisible to our telescopes. Too faint, too distant. In a few years, it will cross Pluto's orbit and then continue outward into darkness. In a few thousand years, it will leave our solar system permanently. And in a few million years, perhaps it will reach another star, another system. Perhaps someone there will look up and wonder, where did you come from? Thank you for watching. And don't forget, if you believe more interstellar visitors pass through our system unnoticed, share your thoughts in the comments. Until next time.